Hi students, welcome to Math Today with Mrs. Berg. We are going to be working on Unit 8 and today it's Lesson 8. So let's go ahead. For today's lesson, you're just going to need a piece of paper or a notebook and something to write with. And it's always good to have a highlighter close by. We will be using a highlighter a little bit today. So let's go ahead and start by getting our paper properly headed. So we're still working in Unit 8. And today it's Lesson 8 and it's called Describing Distributions on histograms. I'll put on a histogram. And I'm going to underline it. So today I'm going to be showing you lots of different histograms. Cool. So it's going to be very important that you're paying attention, and we might even draw some on our paper, which will help you when it comes time to do your homework. And of course, there's a quiz tomorrow. So the first thing we're going to talk about when it comes to describing histograms is something called symmetry or symmetrical. So let's go ahead and write that down. Symmetrical. And it's going to be important that you understand what the word symmetrical means, so we're going to define it. Symmetrical means showing a consistent pattern and then you probably remember this trick: when folded in half, the parts align. So if you have a pattern, a shape, and you fold it in half like butterfly wings, they're going to match identically, and then when you reopen it, you'll have your shape. And this holds true for histograms. Let me show you an example of a symmetrical histogram. Okay. If you look at this histogram, you can see that it has symmetry. Has a nice curved shape, first of all. We have some high points in the middle, some low points on either end. If I were to take this histogram and kind of fold it in half, it would be very similar. Not identical, okay, but in histograms we're looking for, is it similar? Another example of a histogram that has symmetry, I can show you this one. A little bit of a lower peak, not super high, but again, starts low, gets gradually higher, ends low. Here's one that is symmetrical. It's not super exciting. It doesn't have much of a peak at all, but again, if you were to fold it together, it would look very matching. Let me show you an example of a histogram that's not symmetrical. Like, look at this one. We can see that this is definitely not symmetrical. We have a whole bunch of a lot of data over here on the left, and hardly any data here where it kind of comes down and it kind of flattens out. Definitely not symmetrical. Let's look for another one here. Here's another good example of a histogram. You can see a lot of data here on the left, but then it comes down and then it kind of flattens out. Not so much data on the right. Non-symmetrical. So hopefully you realize the difference between something that is symmetrical and histograms that are not. Now, of course, we're not going to sit here and draw each one of these. That's why it's important that you're watching and paying attention to what I'm showing you today for the lesson. So that's the first part of describing distributions on histogram, is are they symmetrical? Something else we're going to look for is something called peak, or sometimes it's plural, and you can have multiple peaks. A peak is simply the highest point on a histogram. The highest point on a histogram. Again, we're not talking about symmetry, just talking about the highest point. So if we looked at this histogram again, the highest point, okay, would be between whatever this was talking about, between 0 and 25. It looks like they had maybe about 25 fit into this highest peak. Look at this histogram. Again, this would be the highest peak here. Looks like it's about 25. Doesn't really matter for today's lesson the data we're talking about, because we're just noticing peaks. Here's another histogram with a very obvious peak. Okay, right here. So peaks, the highest point of data on your histogram. Then we have something called cluster or clusters. Could be singular, we only have one cluster, or it could be plural, we have lots of clusters. So clusters, we're going to say a cluster forms when many data points are near a value. Sometimes you look at these and it looks like all the data value is grouped together. So let me find some examples of clusters. Let's see here. Okay, here's an example of a histogram that has one cluster right here. See a lot of information right here within these couple values, and then it kind of tapers off. So this would be considered, yes, I would say this histogram B, has a cluster. Let's look at this histogram. Again, I see a cluster, I see one cluster right here, a lot of data values clustering around here. This definitely has a cluster. Let's see here, another cluster. I'm trying to find one that might have multiple clusters. See if I can find one. Don't have one. Okay, let's look at this one. Again, I only still see one cluster right here. A bunch of has the highest data. I don't have one, unfortunately, but there are sometimes histograms, guys, that can have two clusters. So like if these were to have maybe gone up higher, pretend they had that, I would then say, here's a cluster and here's a cluster. So sometimes, yes, you can have more than two clusters. If I looked at something like this, guys, this is a relatively flat histogram. I don't really see an obvious cluster. All the values are very similar. So if I was looking at this histogram, I'd say that there are no clusters. Data's pretty flat. You could probably make the same argument for this histogram. No real obvious clusters. No one's coming up real high. So this would be an example of a histogram that does not have a cluster. So hopefully you've seen and noticed examples of histograms that have cluster, have two clusters, or don't have any cluster at all. The last description of a histogram is called gap or gaps. I can make it plural again. Just like clusters and peaks can have more than one, a gap shows a location with no data values, comma, has a space. Has a space. Let me show you some examples of some histograms that have gaps. I've got, let's find one. Oh, here's a great one. Histogram A. If you notice, if I can zoom in just a little bit, we have a cluster, okay, right here. We also could say to this one, we have a peak. The peak, it looks like the peak is kind of in between 25 and 30, so maybe the peak is 27.5. And here's a gap. We have no data, so there's nothing between 65 and 80. It's blank. This would be called a gap. This particular histogram has one gap. Here's an example, histogram G, where we've got a couple gaps. Again, if you look at this histogram, you could describe it a couple ways. We could say, well, it does have a cluster. Okay, it has a cluster, yes. It has a peak. Maybe 25 is the peak, it's the highest point. It's not symmetrical, right? So this definitely would be non-symmetrical. And it has two gaps, here and here. So all of these terms is pretty much what today's lesson is about, describing histograms and saying to yourself, is it symmetrical, yes or no? Does it have any peaks? Could have one peak, could have maybe two peaks. Does it have any clusters? Yes or no? Does the histogram have any gaps? Yes or no? So let's kind of put this all together, and we're going to draw a histogram down here, and we're going to label it so that you are completely familiar with all of those terms that describe a histogram. So let's go ahead and come down 1, 2, 3, 4, 5, 6, 7, 8, and then come over like a big L. Let's go ahead, I'm trying to make this as simple as possible. Let's have down here across the x-axis, let's just start at 10. So we have 0, 10, 20, 30, 40, 50, and we'll stop at 70. Skip counting by 10. And up here, let's skip count by 5, 5, 10, 15, 20, 25, 30, if we have room, 35. Let's just say that at the 0 to 10, we had a 5 that fell into this category. From 10 to 20, let's come up to 15. Shade it. From 20 to 30, let's come all the way up to 35. Come down, shade it. From 30 to 40, let's come up to 20. Come down, shade. From 40 to 50, let's come up to 15, down. From 50 to 60, let's come up to 10. And from 60 to 70, let's come up to 5. Okay, so there's our histogram. Let's talk about this. The first thing is symmetrical. Does it have symmetry? Does it make a nice kind of a bell curve? And hopefully you're saying to yourself, yes. If I were to kind of cut this in half and fold it, it would match up. Not exactly, but that's okay, but fairly simple. It's got two short and then it gets bigger in the middle. So we're gonna say that symmetrical, oops. Yes, so it fits the description of being a symmetrical histogram. Are there any peaks? Remember, a peak is the highest point. So yes, it definitely has a peak. And if I come over, the peak was at 35. So yes, peak at 35. If I ask you, are there any clusters? Hopefully you're going to say yes, because I can kind of see a cluster right around here. Okay, a bunch of high values in the middle and then lows on either end. So yes, it has a cluster, and I just see one cluster. And are there any gaps? Well, the particular histogram we drew, no, there are no gaps. Okay, all the data is right next to each other. If I were to extend this maybe to 80, 90, skip between 70 and 80, and come up and add a little 90, now I would say that we have a gap right here. Okay, just to make sure you understand gaps. If I were to ask you what's the spread of the data, hopefully you didn't forget what spread is. It's the low point, 0, to the high point. So if I do this, maybe I'll say it's from 0 to 90 is the spread. So this is kind of what we're talking about today. So let's go ahead and turn to a fresh page. And I'm going to talk about, remember when you had, beginning of this lesson, you guys had to take a survey and we asked you about 12 questions. So I've taken all that information from both Mrs. Berg's class and Mrs. Pila's class, and I just focused on how you guys get to school and how long it takes you to get to school. So this is all the data. So there's 32 total students between Mrs. Pila's class and Mrs. Berg's class. And if you look at this, 4 students walk, 2 students ride a bike, nobody scooters or skateboards, 5 take the bus, 21 go by car. And then nobody uses public transportation. I'm not sure what the other would be. If we look down at travel time, we have a pretty wide range of data here. Okay, anywhere from 8 students that can get to school in less than 5 minutes to 2 students that travel 40 to 45 minutes to get to school, and a whole bunch in between. So we can take this information, okay, and we can put it on graphs. Now, the one that has to do with time, this would be a perfect graph for a histogram because we have ranges. Remember these? We have bins. We have ranges of data that we can make a histogram together with. All right, so let's go ahead, and this is going to be the next part, and we're going to make a histogram. So let's come down. Let's see here. 1, 2, 3, 4. We have 8. Let's come down. 1, 8, 2, 3, 4, 5, 6, 7, 8, and then come all the way across. So down here, this is going to be our travel time. So let's just label this travel times, and we're doing minutes. Okay, this side here is going to be, I'm going to turn it sideways, it's going to be the number of students. And because the highest number of students that fit into any range was 8, I'm just going to count by 1. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I'm going to make my ranges. So the first range is going to be, and pretty much skip counting by 5, so 0 to 5. Then I'm going to have 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, and 40 to 45 for the longest travel time. Now let's go ahead and fill in our histogram. So we had 8 students that can get to school between 0 and 5 minutes. So I'm just going to kind of shoot straight up to the 8, come over, and come down. And I'm going to shade that in. We had 7 students that could travel. It took them 5 to 10 minutes. So I'm going to come up to the 7, come down to the 10, and shade it in. Hopefully you guys are doing this with me. We had 5 students. So I'm going to come up to the 5. That takes them 10 to 15 minutes to get to school. We had 2 students. So come up to the 2. That takes them 15 to 20 minutes to get to school. We have 3 students. I'm going to come up to the 3. That takes them 20 to 25 minutes to get to school. 5 students. Up to the 5. Takes them 25 to 30 minutes to get to school. We have no students from 30 to 35, so that's called a gap. We have no students from 35 to 40, so now we have a bigger gap. And we have 2 students between 40 and 45, and then that's where our data ends. So this is our histogram. All right. First question, is it symmetrical? Think about what that means to be symmetrical. Hopefully you said, no, it's not, because it starts high and then it kind of tapers off. All right, so we're going to say no, not symmetrical. Okay, what about my next question? Are there any gaps? Hopefully you're looking and you see that, yep, yes, a gap. Our data values have a gap. Okay. Are there any clusters? And you probably could make an argument that maybe there's a pretty big cluster here. You might even say there's another cluster here. So we can say yes, and there are 2 clusters. What about a peak? What is the peak of our data? So what is the highest point? And hopefully you said it's 8 students. 8 students. And lastly, if I asked you what is the spread of our data, you take your high, which is your 0, all the way up to your 45 minutes. So it takes students anywhere between 0 and 45 minutes to travel to school, and then this is all of the specific information. So a histogram is a great way to show that information. Our second information had to do with methods of travel. Walking, biking, scootering. Now in this, because it's categorical data, it's not numbers, okay, meaning these are categories, a histogram's really not going to work well here. So if I had to make a graph for this, I would probably go with a bar diagram, okay, because it's better to use a bar diagram with categorical data. So let's make a bar diagram. I'm going to turn the page, and then this will be the last part of today's lesson. So if we had to make a bar diagram, we would simply still make our L. Come over. Now instead of writing numbers down here, I'm going to write the different methods to go to school. So we have some students walk, some students bike, some students use the bus, and car. So hopefully you wrote that down. And then over here, I'm going to skip count by 5. So 5, 10, 15, 20, 25. And I'm just going to make bar diagrams. So the number of students that walked to school were 4. So I'm going to go almost up there, and I'm going to make a bar. Students biking to school were just 2. So I'm just going to make a little bar at the bike. Students taking the bus were 5. So I'm going to go up to the 5, come down, and make my little bar. Most of the students used a car that was 21. So I'm going to go up here just a little past the 20. And there's our car. So this is a better way to show way to get to school. And so down here I'm going to label it methods of travel. And then on the side here, this is the number of students. And just in case you ever forgot, this is a bar graph. That's just to show you the difference between a bar graph and a histogram. So that's it for today's lesson. In summary, the part of today's lesson that you really need to understand is all these terms and how to display a histogram. They'll help you when you do your Google form today on the lesson. All of this is going to be in there. You also have One Khan Academy. So enjoy your math lesson today, and good luck on the quiz tomorrow. Bye.